In this video, I'll be going over some of the homework problems for the Chapter 7, Day 7 worksheet. We are solving exponential and logarithmic equations. So for problem 1, 2, 3, and 4, you should be able to get bases to be the same, just like Chapter 7, Day 2. But as you move down to problems 5 through basically the end of the worksheet, you're going to have some different work to do. And you'll notice for number 5, I won't be able to get bases to be the same. So when bases can't be the same, you'll take the log on both sides. And the reason why we will use the log on both sides is so that way we can use the power property of a logarithm and move the variable out front. So this would be x times log of 3 equals log of 20. And then to solve for x, you're going to divide by log of 3. So in your calculator, you will take log of 20 divided by log of 3. And so the way that you type that in would be log of 20, close the parentheses, and then divide by log of 3. And that's going to be 2.727. 2.727. And once again, it's kind of up to you. You can use 2 or 3 decimal places for that. But if you look at problem number 6, you'll have to divide by the 3 first. And so you get e raised to the x power is equal to 4. Now, in this particular problem, I'm going to use the natural log because e is already involved. So I'm going to take the natural log on both sides. Now I'm going to use the power property and move that variable out front. So this will be x times the natural log of e equals the natural log of 4. The really nice part is, and we talked about this in the notes, the natural log of e is just 1. So then x is just the natural log of 4, which if you type that into your calculator is 1.386. So your job when you're solving these problems is, and I'm going to set up 7 and 8 for you, is you need to get the base by itself. So for number 7, you would divide by 3. Or in number 8, you would add the 1. But you're going to get the base by itself, and then you're going to take the log on both sides. So I'll let you try those 2 problems. But on the back, what will happen is we already have logs present in these problems. And when you already have a log present, you can convert. So for problem number 9, the base is 10. Power is 2. You're going to set that equal to 3x plus 1, and then you're going to solve for x. So that would be 100 is equal to 3x plus 1, and then you will solve to get 33. In a problem like number 13, you have to get the log by itself. So you would add the 5 over first. So that would be 12, and then you would divide that by 2. So that would be 6. And then you convert. Base is 3, power is 6. And so 3 to the 6 is 729. Now, it's really important here to check your answers as well. I didn't check 9 nor 13, but if you had watched the video for the notes for day 7, basically you don't want to take the log of 0 or the log of a negative number. So if I plug 33 in here, 3 times 33 is 99, plus 1 is 100. We can take the log of 100. Over here, 729, if I plug that in, there is no issue with that. The log of 729 does exist. 729 is positive. So I'm going to end here with problem number 16. 16 has a little bit of work because you have to combine some properties of exponents, some properties of logarithms in order to get down to a single logarithm. So this would be the power property, putting the 2 back on the x, and then the sum of 2 logs is a multiplication. And so this would be, if I convert it, 10 squared is equal to 4x squared. So 10 squared is 100. 100 divided by 4 is 25. And remember, if you take the square root, that's technically 2 different answers. But you can't use the negative answer because if you take the log of -5, it doesn't exist. So there's actually only one solution to this particular problem, which is positive 5. And there's your video.